Hello, hi everyone. Thanks for joining us today. Um, if Just a quick introduction, my name is Shoei. I'm the co-founder of EdXP. If you're a part of our mailing list, you would definitely have received many emails from me. And if you have joined us previously for the other seminars, you would probably have seen me around before. So continuing with our webinar series, today we finally have physics, a very in-demand subject that a lot of students have asked for. And without further ado, I'm going to introduce Ethan to everyone. So Ethan is actually an intern with EdXP. He was a former IB student, okay, and he'll be leading this seminar. Ethan, welcome. Can you just quickly introduce yourself to everyone here and kind of explain your IB experience, the scores that you have gotten and where you're headed to before you jump into the seminar?
All right. Hi. Good morning, good afternoon, or good evening to everyone joining us. My name is Ethan. As Shui said, I'm an intern at EdXP. As for personal introduction, right. So I attained the IB diploma with 43 points overall in 2020. I got a 7 for my HL physics, as well as an A for my physics extended essay. So after completing my IB diploma, I applied to college, and I'm going to go to UT Austin, which is a university in Texas, to study electrical and computer engineering. All right. So without further ado, I'm just going to jump into the presentation for today. All right. The scope for today. Firstly, there's the introduction. I'll give you an overview of the Physics IA. I will analyze the assessment rubric. I'll teach you how to best analyze a topic and how to choose a good topic for your IA. I'll give you do's and don'ts for every part of your IA report. I'll cover some frequently asked questions. And finally, I'll open the floor to some questions. If you do have any questions at any point in the webinar, please feel free to leave them in the chat and I'll answer them during the Q&A. All right, personal introduction, that's been covered already. As for my aims today, I hope that after today, you will be able to confidently approach the Physics IA and you will know how to excel in every part of your IA report. What is the IA? The Physics IA is an individually prepared report investigating some area of physics. It constitutes 20% of a student's final grade for the physics subject. Its purpose is to demonstrate your investigative skills and scientific knowledge in a practical manner. While the IA is an individual report, you can and should use teamwork and collaboration to assist you. This can include brainstorming ideas with your friends as to which topic you should explore for your IA. You can share research resources that you find online with your peers. And perhaps most importantly, you should seek peer feedback for your IA drafts. As for time allocation, you should spend 10 to 15 hours on your report. This relatively short time frame means that the IA should not be an extremely complex or in-depth report. Length. The IA should be 12 to 15 pages long with double line spacing, including diagrams and graphs, but excluding your bibliography. Onto the assessment rubric. Your IA is assessed via 5 components: personal engagement, exploration, analysis, evaluation, and communication. Your IA is marked by your school teacher fully. However, do note that it may be audited or moderated by the IBO if they choose to do so. Onto the first component, personal engagement. The IA rubrics can be found online or from your teacher. So for every slide, I will show a screenshot of the IA rubric and I'll explain what they really mean. Personal engagement. This criterion assesses your engagement with the topic you are investigating. Engagement is shown by creative thinking. This can mean creating an original setup, investigating a novel topic, or other ways of showing that you genuinely are connected to your topic. Do note that there should be a good justification for investigating a novel topic. You won't necessarily be bogged down for a frivolous investigation but a more quote-unquote serious topic gives a better impression to your marker. As an example, I once saw two students that were doing the IA under the same teacher. One of them did his IA on the physics of straws floating in cups of carbonated drinks, and the other investigated the performance of roadside crash barriers. While these are both novel topics and both show personal engagement, the one with a more impactful application, i.e. the crash barriers, looks better to your marker on the first read. Do not force a personal connection with a topic if none exists, because it comes off as phony. You can and should take inspiration from textbook experiments when designing your methodology, but please note that you should not copy wholesale from a textbook. Additionally, you should make your own diagrams. You can do this using Google Slides, or Microsoft PowerPoint and Word have their own diagram creation functions. Please remember, do not stress over getting 2 marks for this criterion. Don't bite off more than you can chew. I've seen students try to do a really out-of-the-box investigation, but sometimes they don't have the capability to overcome every obstacle. They might have to end up changing to an easier topic down the line. What do you get out of this? 1, you wasted time that could have been spent writing your IA or on other projects. And 2, you stress yourself out. Remember everyone, it's an IA. Do it simple, do it clean, and do it good. Exploration. This criterion assesses your investigative process. And this criterion assesses your investigative process as well as how you present it. Your report should be 3 things. It should be coherent, well-organized, and concise. Coherent. Your report should be logically developed, easy to follow, and it should meet its stated aim. Your parts of your report should be well linked to each other. I will show you how to do this later. Your report should be well organized. The relevant graphs, tables, and diagrams should accompany your work. As a general rule of thumb, they should not be more than half a page away from their first mention in the report. Information, for example, large data sets, additional graphs, as well as diagrams and tables, should be put in appendices if they are too long. The report should be concise. Your exploration should not have any irrelevant or unnecessary repetitive calculations, graphs, or descriptions. Here are a few examples of well-linked parts. You should anticipate what your reader will be thinking or wondering about and address it in a way that leads on or links to the next part of your report. Let's consider the first example. In this first example, the report says the braking force on the magnet was calculated for each value of D. A reader's natural reaction is to wonder how the braking force is calculated. The report then segues into variables, as you can see in bold, and answers this question by elaborating on the experimental setup. In the second example, it says, since the value of FB was derived from the acceleration of the magnet, other variables that could influence the acceleration of the magnet were kept constant. Naturally, the reader will wonder about what variables the report exactly means. Thus, the report exactly explains what variables were controlled and how they were controlled. You can and should use words like thus or hence to link the parts of the report to the previous parts. By connecting the different parts of the report well, it makes the report more coherent and it shows your marker that you are thinking about what you were doing. You should justify the choices and mention assumptions that realistically might not hold true. For example, in your experiment, if you're using a magnet to attract or repel something, and the strength of the magnetic force is relevant, a possible assumption you might want to put down might be the magnet strength degraded with time. Don't waste space saying assumptions that realistically won't change. For example, you should not include an assumption such as the gravitational field of the Earth might have changed during my IA. Realistically, the gravitational field of the Earth is not going to change to an extent that affects the magnitude of your calculations. So don't waste space or time writing an assumption like this. At the end of the day, you should ask yourself, does everything in your IA contribute to the flow shown below? Why is your RQ important? How did you investigate the RQ? What are the results of your investigation? And what are the meaning of your results with respect to the RQ? Whenever you're writing a part of the IA, ask yourself, does this part contribute to the flow? If a particular sentence or a particular paragraph does not contribute to this flow, get rid of it. It will make your IA much more concise. Analysis. This criterion assesses your data processing skills. I get asked a lot, how much data should I include in my IA? As a general rule of thumb, for quantitative data, you should aim to have 5 to 7 data points, and each data point should have 5 to 7 repetitions each. Do note that the bulk of your analysis should be on your quantitative data. As for your qualitative data, if it is relevant, mention it. Do keep the mentions of your qualitative data brief. You must show sample calculations for one data point, and you should have at least one original graph in your IA. When I say original graph, I mean a graph that you created from your own data that you collected and processed yourself. Evaluation. This criterion assesses your awareness of the significance and the limitations of your IA, discussing strengths and weaknesses of different approaches. We should discuss the sources of error and show that they do not significantly affect the validity of your findings. If at any point in time, you find that a source of error significantly affects your findings, you should go back and fix it such that the source of error is no longer significant. Communication. Define all key terms that are used, be concise, and use scientific symbols where appropriate. Here are some examples of what I mean. As for being concise, on the top, I have a real example from a student's IA. We can cut the fat from the top paragraph and shorten it simply to, I observed a phenomenon when I was cooking with my grandmother. I did not know why such a phenomenon occurred. Oil is essential when frying food. The benefits of being concise are twofold. The report is more coherent, and you free up space for more meaningful content and analysis. As for usage of scientific symbols, consider the top example and the bottom example. You will note the difference, which is in the bottom example, the scientific symbols for F, M, and A are used, there are symbols used for F, M, and A compared to the top example where they are in plain text. Please use your scientific symbols correctly. This prevents confusion, especially if you're working with acceleration, because the symbol for acceleration A can often be confused with the word If you're wondering how you should write scientific symbols on a Word document, I can suggest that you change your font, you write out the symbols in plain text, and then you change the font to Times New Roman. From there, you should italicize the chosen symbol, which will make it look like a symbol instead of a plain text letter. Alternatively, Microsoft Word and Google Docs do have insert symbol features. How to approach your IA. I'm now going to show you a process by which you can come up with and decide on a good IA topic to tackle. There are 3 stages. Brainstorm, consider, and then decide. Brainstorm. Write down all topics that interest you or real-life situations where you know that physics is at play. I would suggest you sit in front of a blank piece of paper and literally write down everything that comes to your mind. Step 2, consider. Consider the variables that can be investigated for each possible investigation. Think about feasible methodologies and setups, and make skeletons to see how your IA could potentially turn out. Lastly, decide. Choose one with a suitable depth that can be completed in a suitable time frame. When I say suitable depth, I mean, as I previously mentioned, 12 to 15 pages excluding your bibliography. Suitable time frame. It's important for you to consider the other projects that you are handling as you are writing your physics IA. For example, if you really have an EE or another subject IA that demands a lot of time, you might want to choose an IA that requires you to spend less time in your lab. All right, here are some examples of potential investigations. For each of these, I thought of a real life situation, I considered the physics involved, and then I came up with an example RQ. The first one, magnetic braking, which is where magnetic force is used to slow down objects or other machinery. Physics involved induction of magnetic fields and electrical currents. An example RQ could be, how does the distance between the magnet and the conductor in an eddy current brake system affect the produced braking force? Next up, deep frying food. What are the physics involved here? Viscosity, thermophysics. Hence, an RQ could be, how does a change in temperature of sunflower oil affect the viscosity of the sunflower oil? Lastly, I thought about car brakes. The physics involved are friction and thermophysics again. An example RQ from the topic of car brakes could be, how does a change in temperature of a car's brake disc affect its braking force? Please note, you should always keep your RQ simple. Your RQ should take the form, how does A affect B? So it's clear to your marker what your report is about and what your independent and dependent variables are. Do's and don'ts. I'm going to run you through do's and don'ts for every part of your IA, starting with the introduction. Do state your RQ. You should explain the significance of your RQ, i.e. why your RQ is important and why it is worthy of investigation. State the aims and objectives of your report and briefly introduce your variables. You should introduce your variables and give a brief explanation of how you're going to investigate them. The complete explanation of how you control and change your variables should be under your methodology. You should also explain how your experiment will answer the RQ. As for don'ts, do not write a fake story about why you're passionate about your RQ. I see many students do this, and it just comes off as phony and it wastes space for your IA. Background information and hypothesis. Do research your RQ thoroughly. You should explain uncommon concepts and jargon and justify your methodology with existing theory. When I say justify your methodology with existing theory, you should you should list out the different possible methodologies that you could have used to investigate the relationship between the two variables. You should justify why you chose your methodology over the others using the existing scientific theory. If your teacher requires a hypothesis, you should include a measurable hypothesis. Whether or not you actually need a hypothesis is up to your teacher. Remember everyone, your teacher marks your IA. Ask them what they want and deliver on it. As for don'ts, do not include irrelevant or obvious information. Variables. Your independent and dependent variables should be measurable and quantitative. What do I mean when I say measurable and quantitative? This means that there should be a number that you can obtain from some measurement that gives a concrete and non-changing meaning to what your variable is. For example, the length of this ruler is 4 cm, the mass of this object is 8 kg. These numbers should be measurable and quantitative. List all controlled and uncontrolled variables. You should take effort to minimize the number of uncontrolled variables. Do note that in your report, you should justify why each controlled variable needs to be controlled and explain how each controlled variable was controlled. As for don'ts, you should not have more than one independent variable and you should not have more than one dependent variable. There is not enough space within the 12 to 15 page limit to meaningfully analyze more than one independent or dependent variable. Methodology. You should explain your methodology clearly such that the experiment is exactly reproducible to someone that has no other contact with you other than the report. Do state the exact values used in your experiment. The precision of your values should be consistent. That is to say, all your lengths should be given to the same decimal point, and all your masses should be given to the same decimal point, etc. Do remember to insert a clear labeled diagram for your setup. As I have previously mentioned, this diagram should be made by yourself. Mention all safety, ethical, and environmental precautions, even if they're obvious. If there are none, then clearly say so. As for don'ts, do not skip explanations for any step. You should assume that your reader has no idea about anything about how to design an experiment on their own. You should not omit safety precautions because IB will mark you down for doing that. Raw data. Do label your tables clearly. You should include uncertainties as well as units in table headings. If there is a small amount of raw data, that is to say less than 1 page, include it all within your IA. If not, put it in an appendix. Do note that this appendix will not be counted within your page count. Highlight anomalous data points and discount them. If you notice that every data point within a set of if you notice that a particular data point within a set of repetitions is anomalously high or low for no particular reason, you should highlight it, label it as anomalous, and discount it. That is to say, you should remove it from the calculations and pretend that it never happened. Don't. You should not have more than 7 replicates for each data point. It's a waste of time. Here at the bottom of the screen, I've included an example of a good table. Do know what's good about it. It has a name, figure 4. It has a title, i.e. table of raw data of current and potential difference against temperature. And each column comes with the variable that is being measured, the unit of the variable, as well as in brackets, the precision of that variable. Sample calculations. Do explain in samples and calculations while they're being presented. Don't just leave a big mess of mathematical manipulations for your reader to try and sort through. Use proper mathematical notation and scientific symbols during your calculations. As for don'ts, you should not show calculations for more than 1 set of data. It's a waste of time. Analysis. Do explain why uncertainties don't affect your trend significantly. That is to say, for your error bars, you should not be able to draw an opposite trend, a trend opposite to what you're suggesting through all the error bars. You should have a graph that represents all your calculated data points. If your graph is linear, you can use the error bars to show the maximum and minimum gradients of your trend. This is the margin of error in your gradient value. When I say maximum and minimum gradients, what you should do is draw the steepest possible line and the shallowest possible line that pass through all of your error bars. Do not have a graph that is hard to read or cramped, and you should not force fit a trend that is not justifiable from your data. All right, here's a little exercise for everybody. On the left of the screen, I have a good graph, and on the right of the screen, I have an example of a bad graph. Can you guys use the chat and tell me why do you think the bad graph is bad? As a hint, there's more than one correct answer. All right, it seems like I'll just throw you guys a bone here. There are several reasons as to why this bad graph is bad, some of which are related to scientific analysis and some of which are related to presentation. The first thing that we should notice is that there are too few data points in the bad graph. I previously mentioned that you should have 5 to 7 distinct data points on your graph. Okay, right. So I'll just explain to everybody why. All right, yes. If you guys are free to are free to chat. Then you guys can type your answers in the chat. All right. I think I'll go back to it. I'll go back and explain the different points as to why this back graph is bad. So as I was saying, there are too few data points on the back graph. There are only 3 data points, but you should have 5 to 7 on your graph. Secondly, the range of the horizontal axis is not appropriate. You will note that the data points stop at 10 mm, but the horizontal axis travels all the way. The horizontal axis travels all the way to 30 millimeters. As a general rule of thumb, the horizontal axis should go no further than 40% of the largest data point. 40%. So in this case, there will be 140% times 10 is 14, meaning that your axis should stop somewhere around 14 or 15. This rule also applies to the vertical axis. There are also some presentation points. The color of the data points, as well as the color of the trend line, are a poor choice. They're both light gray, which makes them blend into the background of the graph. Your data points and your trend line should stick out very clearly on your graph. This will make it easier for your reader to read. This will make it easier for your teacher or your marker to read and understand the graph. Secondly, I will also say that the axis labels are too small. If you compare the axis labels on the good graph versus the bad graph, you will see that the good graph has much bigger and much easier to read labels. This might confuse your reader. But perhaps the most egregious thing about this bad graph is this. You can draw an opposite trend through the error bars. The bad graph is suggesting that there is a positive and increasing linear line that connects these 2 data points. However, these error bars are so big that it's possible for me to draw the literal opposite of this trend through the error bars. If at any point in time you realize that your margins of error are accumulating to something like this size, and you realize that you can draw the opposite trend through your data points, you need to go back to your drawing board. Change your methodology, change the instruments that you're using for your experiment to reduce the size of the error bars to the point where the error bars are like the second graph, where the error bars are like the good graph, where no matter how hard I try, I cannot draw a negative line or the opposite trend through the error bars. Evaluation. Do discuss your results. You should compare your results with other research, and you should evaluate the accuracy, advantages, and limitations of your investigation such that you can answer the question, how well is your RQ answered? You should also explain what your results mean with respect to your chosen real-life situation. As for don'ts, do not brush over your sources of error. Just because you have a lot of elaboration on your sources of error does not mean that you did a bad job designing your experiment. Every experiment innately has sources of error, and acknowledging it does not take away from your score. As a rule of thumb, you should have a minimum of 2 random sources and 2 systematic sources of error. For your systematic sources of error, you should mention which way these sources of error will skew your data and why. Conclusion. Do share distilled conclusions and results. You should summarize what implications your report has. And as for don'ts, do not write about how accomplished, proud, or fulfilled that you feel. References. Ask your teacher what they want. What style will your teacher or your marker like your citations to be in? Do they want it in APA? Do they want it in MLA? Or perhaps Chicago? Additionally, you should ask your teacher if they want footnotes or not. Some teachers do want them, some teachers don't want them. Regardless of what your teacher wants, remember that it's a good idea to cite multiple sources for important pieces of information. You should also take the effort to cite every single one of your sources. I'd go so far as to say that you should check your internet history after you're done with your online research to make sure that you did not miss a single link. As for don'ts, do not cite dodgy sources, including Wikipedia. Yes, Wikipedia has its own experts that keep Wikipedia reliable, but it's not a good practice to cite Wikipedia because anyone can edit it. As a tip, you can use Wikipedia to understand or explore the topic, and then when you are citing your research, you should cite the sources that Wikipedia cites, because Wikipedia sources its information from reliable scientific journals and articles. Miscellaneous tips. You should get 2 friends to read your IA draft. One friend should be strong in physics, and another friend, unfortunately, should be weak in physics. You should write your report such that the friend who is weak in physics can understand the report without any help or any research done on his part. Your friend who is strong in physics can check the report for errors. Read your seniors and friends' IAs to collect good ideas. Lastly, consult your teacher regularly. They mark your IA, so please remember to listen to their advice. When they tell you something, you should write it down, and after you have amended it, check that everything that your teacher has told you has been fixed. This is a surefire way to increase your score from your first IA draft to your final IA submission. Frequently asked questions. What is the difference between a physics IA and a physics EE? An IA is a less extensive report than the extended essay. It has less depth and is shorter than the EE. Can students in the same school or class explore the same physics phenomena? Yes, they can, but do note that your explorations must be different because plagiarism is not allowed, and they must be very clear that the data that both you cite is different. How much help can a student get from his physics teacher? There is no set limit to the amount of help a teacher can give. Students should seek clarification and input from your teacher wherever necessary. Guys, sometimes I hear people saying, oh, I'm shy to ask my teacher because I've asked him for help already. There's no need to feel ashamed. Your teachers are here to help. Seek clarification, seek input, seek all the help that you can get. What should the target audience be for a student when writing their exploration? Your exploration should be accessible to fellow students. Can students explore physics that is outside the IB syllabus? Yes, you can. Novel topics score higher in the personal engagement criterion. Lastly, what constitutes good citation practice? Citations should be given whenever work, ideas, or images that are not the student's own are used. Do note that it is not sufficient just to give a bibliography at the end, and students should cite the sources at the appropriate points in your exploration.
I think that's the end. And thank you, everyone. And I hope you guys enjoyed the seminar. Okay, thanks, everyone. Bye-bye.
Thank you, everyone. Good luck with your IB journey.